the binomial distribution. This discrete probability distribution is explicitly on the syllabus. The binomial distribution is the probability distribution of the number of successes arising from a fixed number of Bernoulli trials. So we've looked at the Bernoulli distribution, and now what we're doing is a series of those trials. Bernoulli trials, remember, only have two outcomes, and we call those two outcomes success and failure. The properties of a binomial distribution are as follows. We have a fixed number of trials, n, so we might do 10 tosses of a coin, for example, or plant 20 seeds. So it's always a fixed number of trials. The probability of success has to remain constant. The trials have to be independent, so one trial does not affect the next one. In practice, the binomial distribution is used in cases where the trials are not independent, but the probability changes only a very small amount from trial to trial. The binomial random variable is the number of successes from each set of trials. If a discrete random variable x follows a binomial distribution with n trials and probability of success p, we write this, and it just simply means that the random variable x follows a binomial distribution with n trials and probability of success p. It can be shown that the probability of x being x is nx, and remember that that is a notation for ncx multiplied by the probability of success to the power x, and if we have x successes, then we must have n minus x failures. It can also be shown that the expectation of x is n times p, number of trials times probability of success, and the variance of x is np 1 minus p, or npq, if we say that q is the probability of failure. It follows that, since standard deviation is the square root of variance, that the standard deviation is the square root of np 1 minus p, or of course if we use q for failure, npq.